I'm going to show you how to run a one-way ANOVA in Microsoft Excel. The data that I have here is 3 different groups, and the groups represent the number of hours that they participated in a program. And then my dependent variable, or my outcome I'm looking at, is the score that they got on a language test. So I want to run the one-way ANOVA to see if there's a difference among the groups based on how many hours they participated in the program. So I'm going to go up to the Toolpak. I'm going to click Data, and then Data Analysis. This is going to pop up the dialog box, and for one-way ANOVA, I need to select ANOVA Single Factor and click OK. For my input range with an ANOVA, I just select all of this as one block. Sometimes we enter the different groups in different boxes, but right here I just select it as one block. And then I need to tell it whether my data is grouped by columns or rows. Here my data goes down, so this is grouped by columns, so this is correct. And then I did select those labels, so I'm going to check this box. Significance level of 0.05 is good for what I'm doing, so I'm going to leave that. If I was using a different significance level, I would just change that by manually typing that into that box. And the next thing I'm going to do is change the output range, because I like to have my results somewhere on the same tab where I'm already working. So I'm going to choose this for my output range and then click OK. And this is going to give me my ANOVA results. And the first table here is a summary. And it's going to give me the summary for the groups. It tells me how many were in each group, the sum, the average, and then the variance for each of those groups. If my results are a little off or something doesn't look quite right, this is a good spot to check. I can look and see that I have 10 in each of the groups, and that's what I was supposed to have, so that works out great. And then down here are my ANOVA results, and it gives me my between groups sum of squares and my within groups sum of squares. It also gives me my degrees of freedom for between groups and within groups. And what I really want to look at is this F value. The F value is 8.799, and my P value for that result is 0.00142. So if I compare this to the significance level that I chose, which was 0.05, that P value is much smaller, so that is going to be a significant result. And with that in mind, I will reject my null hypothesis. And I will conclude that there is a difference among the groups based on the number of hours that they participated in the program. I could also use a critical value, and when I use a critical value, I'm looking to see if my F value that was calculated is more extreme than the critical value. So in this case, my F value is 8.79, and my critical value is 3.35. So any result beyond 3.35 is going to lead me to conclude that there is a difference among the groups. And so I would also reach the same conclusion if I used the critical value, which is part of the output that Microsoft Excel gives you. I'm going to show you another example. So in this tab I have my results just to check myself. It looks the same. And then I have another example looking at blood pressure by age. So I want to see if there's a difference in blood pressure for people under 20, 20 to 40, or over 40 years of age. So is there age a factor in blood pressure reading? So I'm going to go up to the Toolpak again, go to Data Analysis, click on that, and then single factor pops up because I just used it. So I'm going to click OK. And I enter all of this as one block of text, remember? It's remembering what I just did, but my data range is a little different, so I want to select all of this. And I want to also show you this example because you do not have to have the same number in each of your groups to do the one-way ANOVA. And in that case, I just select all of this as one block of text, even if the groups are unequal sizes. And my data is grouped by columns, so that is correct. I did select those labels, and I'm okay with that significance level. But it's remembering the output range I used last time, which in this case would actually override some of my data. So I need to adjust this. Click OK. Oh, and it put both of those in there, so let me delete that. Sometimes something like that happens, that's why I always double check it. All right, so let me double check everything, and it looks good, so I will click OK, and I get these results. Again, the first table is the summary. It gives you summary results for each of the groups. And then down here, I'm just going to make this a little wider so it's a little easier to see. So here I have my degrees of freedom for between groups and within groups. And again, what I want to look at is my F value, which is 0.405. And then I look at my p-value, which is 0.66935. And using that 0.05 level of significance, this p-value is much larger. So when my p-value is larger than my level of significance that I've set for my test, that's going to lead me to fail to reject the null hypothesis. And in this case, I'm concluding that there is not enough evidence to indicate that there is a difference among blood pressure based on age group. I could also look at the critical value of 3.25, and again, I'd be looking for a result to be more extreme than that. And 0.40 is much smaller than my critical value. So I would reach the same conclusion and I would fail to reject the null hypothesis. Just want to note that you will not get a negative value for your F value. The way that the formula is calculated, it's only possible to get positive values. So sometimes we're looking for a critical value to be either positive or negative value, like with our t-test, but with the F value, it's only going to be positive because we're squaring everything that goes into that final result. And on the second tab, I have my results for that test. I just put the table to the side instead of below it for this one. And that is how we would run a one-way ANOVA using the Microsoft Excel Toolpak.